Hi everyone, I'm Hong Pan, and today I'm going to focus on a brief introduction to the hypothesis and portfolio building methodology in Project 2, and we also talk about its implementation in the code base. First, the purpose of Project 2 is to test the effectiveness of a long-short strategy based on total volatility. Our null hypothesis is that the average return of a portfolio with long and short volatility is zero. This means that there is no significant difference in returns between the high volatility and the low volatility portfolios. The alternative hypothesis is the average return of a portfolio with long and short total volatility is not zero. This means that there is a significant difference in returns between high volatility and low volatility portfolios. Now, let's discuss the portfolio construction methodology in detail. The construction of the investor portfolio is divided in 3 parts, each of which has multiple steps. The first part is data collection. The purpose is to obtain the adjusted closing price of the stock in a specific time frame and calculate the daily and monthly earnings. Firstly, we use the write price CSV function to read the price data. In this function, the key is to use the stock index and select the specified data range and deal with missing values. Second, we calculate the daily and monthly returns using the daily return calculation and monthly return calculation functions, both of which need to handle missing values. And when calculating the monthly returns, we use the resample function to resample the daily price to the price on the last trading day of the moon. Finally, we combine these functions into a function adjust return dictionary that generates an earning dictionary. We have the function perform the step of reading the price data for each stock symbol, calculating the daily and monthly returns, and storing the daily and monthly earning data in the dictionary. The second part is characteristic calculation, which aims to calculate the total volatility of each stock. First, we check with the volatility input sanity check function, where the important points are to ensure that the input return is a dictionary containing daily and monthly returns, and characteristic name is a string, and the return frequency used is a list containing veiled values. Second, we use the feature calculation function, volatility calculation, in which we need to select the daily returns from the input returns dictionary. Then group them by month and calculate the standard deviation. And finally, perform the processing of the missing value. Finally, we use the merge table function, merge tables. We select the monthly return data from the input return dictionary and merge the total volatility data table with the monthly return data table by date. The next part goes to the next speaker.
The following part focuses on constructing the portfolio based on the previously calculated characteristics. This part involves several key steps: input validation, data reshaping, stock sorting, and portfolio calculation. Let's break down each step in detail. First of all, input sanity check. The purpose of it is to ensure that the input data form and characteristic name are correctly formatted and contain the necessary data. The key step is to verify that the characteristic name is a valid string. Check that the data frame index is in monthly frequency. Ensure that the characteristic column are correctly formatted and match the return columns. Second, Data reshaping. The purpose of it is to reshape the input data frame so that each row represents a specific ticker along with its returns and characteristic values for each year and months. The key step is to identify tickers in the data frame, extract relevant data from each tickers and concatenate into a single data frame. Thirdly, stock sorting. The purpose of it is to sort stocks into quantiles within each year and months based on the specified characteristics. The key step is that group the reshaped data frame by its period index and apply a quantile cut to the characteristics. Assign a rank to each stock based on its quantiles. Fourthly, portfolio calculation. The purpose of it is to calculate the equal-weighted portfolio for each quantiles and construct the long-short portfolio. The key steps is that group the sorted data frame by index and rank, then calculate the mean return of each quantiles. Create data frame size for each quantiles and concatenate them. Calculate the long-short portfolio by subtracting the returns of the lowest quantiles from the highest quantiles. Finally, portfolio construction main function is to coordinate the entire purpose of portfolio construction by calling the above function. Now, let's discuss the result of the long-short portfolio. In part 9, we calculate the average return of the long-short portfolio and t-statistics. The result shows us the average return of the long-short portfolio is 0.0070, and the t-statistics is 1.3513. This indicates that although the average return of the long-short portfolio is positive, its statistical significance is low. We need to discuss the reliability of the result. First, the t-statistics of 1.3513 is not sufficient to reject the null hypothesis at conventional significance level. This suggests that the observed average return may not be significantly different from 0. Second, the sample size is relatively small, which might limit the robustness of the result. Finally, the quality of data and market conditions can also affect the result.
Hi, let me talk about the further work plan. To further validate and improve our strategy, we plan to undertake the following work. First, expand the sample size. We can include more stock and extend the time period to increase the robustness of the result. Second, out-of-sample testing. We can test the strategy on out-of-sample data to check for consistency and robustness. Third, risk adjustment. We can use the CAPM or Farmer-French model to adjust for risk factors in the returns. Fourth, explore alternative strategies. For example, momentum and value strategies, and compare them with the volatility-based strategies. 5. Robustness check. You can conduct subsample analysis and compare different volatility measurement methods. 6. Integrate machine learning techniques. We can enhance stock selection and portfolio optimization using machine learning. 7. Conduct economic analysis. We can investigate the economic reason behind the profitability of the long-short strategy. Today's presentation covers project use hypothesis, methodology, result, and further work plan. That's all for our group presentation. Thank you for listening.